Okay, just like most functions, the sine, the cosine, the tangent, the cotangent, the secant, the cosecant functions also have graphs. And so they start by analyzing a little bit about the graphs of the sine function and the cosine function, which he has written y equals sine theta, y equals cosine theta. Alright, in fact I probably should put thetas over here because he's probably using that as the variable theta here. I like x because I'm used to x's and y's. Alright, now we already know, or we know most of the unit circle. So if I was to attempt to graph y equals the sine of theta, I would want to plot some points, just like I did when I was learning how to graph lines and parabolas. So I pick a whole slew of angles here, as you can see. Or can you see that? No, you cannot. It is off the screen. Let's see if I can get it, pick that up a little bit better. Now you can see them. All the multiples of 30 and 45 are all the multiples of pi over 6 and pi over 4, all the way down. And I write down the values. Now notice that the square root of 2 over 2 is about 0.7. The square root of 3 over 2 is about 0.86. So I use those approximations, and as you can see here with the green line underneath this top graph, I graphed all of those points, and you see the curve. The curve, if you connect the dots, is referred to as the sine wave. See if I can connect the dots. And since we have periodic functions that repeat every 2 pi, this graph would continue going to the right and to the left. Now notice here I graphed in all the points there because I wanted to show you exactly what the curve looked like best that I could do it freehand. But I'm really just interested when I'm learning to graph the sine of theta and the cosine of theta on my highs, my lows, and my x-intercepts. And as you can see, the x-intercepts repeat every pi, so I'm going to have an x-intercept here as well. And you can see that first it's high, then it's low, so then in the next pi over 2 up, it's going to be high again up here, and it's going to be low down here, and back up to high here. And you can see the wave continue. Now I'm just going to make this as smooth as I can. It's not a bunch of V shapes, so don't connect the dots like little line segments, put a curve to it. And this graph continues forever and ever and ever. Now notice here that the biggest value is 1, the smallest value is -1. Okay, and see how your graph goes with the highs and the lows. Well, we describe the highs and the lows with a term called amplitude. The amplitude is kind of like the middle of the highs and the lows. So what you do is you actually average the maximum value and the minimum value. I take that back. We don't average them. We subtract them to find the distance and we divide by 2. Said the wrong thing. We take the maximum value, subtract the minimum value, divide by 2. So the maximum value is 1, the minimum value is -1. 1 minus a -1 divided by 2, which turns out to be 1. So as it turns out, for both of these functions, the amplitude is 1. The other 4 trig functions don't have amplitude, as you'll see when you get to those sections where you're graphing those. But for sine, for cosine, they do have amplitude. Alright, now, the period of both of these functions is 2 pi, because it repeats every 2 pi. It doesn't matter where you start. So I start up here at the high, from -3 pi over 2. Next time I get to the high, I'm at pi over 2. Well, the difference here of these two values, this distance is 2 pi. This distance between this x-intercept and this x-intercept, 2 pi. See how it starts going up, then it comes back down, hits here at the x-intercept and starts going up again. It repeats its values. It's sometimes referred to not only as periodic, but cyclic, a cycle. Now, below here, I have graphed and created a t-chart for the cosine, y equals the cosine of theta. So I picked all the same angles that I did for sine, and I found the values, remember from your unit circle, with my approximations there, and I graphed these points. Now you can see you have a similar looking shape, but it's not the same exact graph, whereas this graph kind of starts at 0, 0. At 0, 0, this graph starts at 0, 1. But it does follow that same kind of a wave or curve And I'll do the best I can here. And then this would continue in both directions again. And you can see that it repeats, or it has an x-intercept at every pi unit, so it's going to have an x-intercept here, it's going to have an x-intercept here, it's going to have an x-intercept here. It's up high here, it's going to be down low here. And my graph, if I was to continue it, would look something like this. Something like that. Again, the high is 1, the low is -1, 1 minus a -1 divided by 2. It also has amplitude 1, and it has the same period. The period is 2 pi. Look, start here at 0, 1. I don't get to 1 again till here at 2 pi. A difference here of 2 pi units to the right. So this is periodic, and we say that the period, or sometimes they call it the fundamental period, is 2 pi. Now, I don't expect that you're going to have to write all these out and graph them from scratch. The key to graphing these are finding the x-intercepts, the highs, and the lows. Because once you have that pattern going, you can graph as much as you need. Now, over here, we have some transformations. Here with the A and the B. The A is a vertical stretch or shrink, the B is a horizontal stretch or shrink. That means the A affects the period, the highs and the lows. The B, as I just said, the period, the amplitude, the highs and the lows. B affects the period because it's stretching it horizontally. So it's either going to increase the period or it's going to decrease the period. It's either going to stretch it or shrink it out. Same thing here for cosine. Now I went ahead and used the letters A and B because those are the ones that are typically used. And A might be positive, A might be negative. I think in this section with your assignment, I think all the A's are positive. And I think all the B's are positive. Otherwise, you've got some reflections. If A is negative, you have to reflect it. But the amplitude is going to be the absolute value of whatever this constant is, that's times your trig function. So look right here. I have 2 times the cosine of theta. My amplitude is the absolute value of 2, which is 2. Now, there is no number times the theta. There's no b. B is 1, if you want to think of it. All right, to find the period, we take the period of the original function, the fundamental period of 2 pi, and we divide it by the absolute value of b. Well, in this case, b is 1. So 2 pi divided by 1 is just 2 pi. So the period does not change, but it has been stretched. If this number is greater than 1, it stretches it. If it's between 0 and 1, it compresses it. In reverse, if this number, like I have here with the 1/3 times theta, theta times 1/3, or theta divided by 3, if this number is bigger than 1, it shrinks it in because you're dividing 2 pi by that number bigger than 1. It's going to make it smaller. If 2 pi, or b is between 0 and 1, it's going to stretch it out. It's going to elongate it, just kind of like a slinky. You remember the slinkies? You stretch them out, shrink them in? All right. So if I'm going to graph this guy, I remember, where do I start at? I start at 0, 1. But when I plug 0 in here, I'm not going to get 0, 1. The cosine of 0 is 1, but it's going to be times 2. It's stretched out. The highs and the lows are now going to be doubled. So it's going to start out at here, at 0, 2. Now, the period didn't change, so you'll notice that it crosses here at pi over 2, so it's going to cross right here at pi over 2. And then it's going to bottom out down here at when x is pi, or theta is pi. Then back up here, and then all the way back up to here. And I would just continue. Well, that's not very well lined up there. Let's try that again. And I would just continue following this pattern. Now, if you don't get the pattern right, you're going to mess up the whole graph. So be very careful making sure of your pattern, making sure of your amplitude, and of course here they also wanted the period. The period is 2 pi. All right, so now my graph is going to look something like this. Whoops, not very good. And as you can see, it's the same kind of a curve, same kind of a sine wave, sinusoidal, I believe is the way they describe graphs that have this sine curve or cosine curve. And it continues on forever and ever in both directions. I don't think he's going to want you to put arrows on there. I suppose if you did, that would tell him that you know it goes on forever and ever, but he probably is only asking for no, just this graph, so it doesn't have any restriction on as far as that's concerned. All right, now here's one In this example, in which they, let's see, let me use my black pen here, in which they are asking you to find, or to graph y equals the sine of theta over 3. Now theta over 3 is the same as the sine of 1/3 theta. So you can see here B is 1/3. So B is 1/3, A is 1. So since A is 1, I know that my amplitude does not change from the parent graph over here. The parent graph's over here, amplitude. These are, by the way, referred to as the parent graphs for sine and for cosine. The amplitude is going to be 1, but the period has changed. You take 2 pi and divide it by the absolute value of 1/3. So 2 pi divided by 1/3 is the same as 2 pi times 3 over 1, which is 6 pi. So the period has been stretched. 6 pi. Like that slinky, you're stretching it out here. So it does a complete cycle in 6 pi. Now notice here, sine. Sine starts at 0, 0. If I plug 0 in for theta, 0 divided by 3 is 0, the sine of 0 is 0. So I'm starting right here. Now I'm going to use a different color. I think I got a green one somewhere. Here we go. So I'm starting right here. But instead, now notice my scale here, right? I saw it coming, and he's got it already set up that way on his worksheets and such. I get a complete period in 6 pi. That means I have to be back here in 6 pi. I'm going to have to be back here in 6 pi. So I've got to go up and down and back up to here, which means halfway in between is my next x-intercept. I'm going to peak up here. I'm going to bottom out here. I get that all from knowing a little bit about the parent graph on sine. So it's going to be here again. I'm going to peak up here. I'm going to bottom out here. And you can see here's the curve. Or try to draw it here. Be very careful with the scale that he gives you. Don't assume that the scales are all the same. And this continues in both directions forever and ever and ever. Now the only thing that I haven't shown you an example of, and I don't know if I can do that on any of the ones that I have here marked, is one where you have a change in amplitude and a change in period. How about problem number 9? Problem number 9, here we'll use this one over here. It might not be tall enough because there's a 3 there. Well, we'll stretch it. So I'm going to come back over here and I'm going to try to do problem number 9. So I'll erase the existing graph there that has all that information. So let me erase this for right now. And for problem number 9, my graph is going to have to, at least my y-axis, it's going to have to be a little bit stretched out here. So I'm going to continue this. So that distance there is 3, negative 3, and dum might be up here at positive 3. And I think I can squeeze everything else in. So we're going to do problem number 9 here. Y equals 3 cosine 2 theta. Well, there are two things happening. There are two transformations. You're getting a stretch vertically, because it's changing the amplitude. The absolute value of this is 3, and that's greater than 1. And we're going to get this shrunk this time, because this is a value greater than 1 here as well. So the period, here, maybe I better write that someplace else. Here, let's put it next to it. The period and the amplitude, well, the period is 2 pi divided by b, which is 2. A is 3, b is 2. So that means that the period is pi, or 180 degrees. The amplitude is the absolute value of A, so it's 3. So that means my highs and my lows are at 3, and it's been shrunk in this way. I have to do a complete period now between 0 and pi. Now remember, with cosine, there's the parent graph for cosine. It starts at 0, 1, not this time. If I plug 0 in, 2 times 0 is 0, the cosine of 0 is 1, times 3 is 3. I start way up here. Let me get a different color here. Way up here. So the highs are going to be 3, the lows are going to be -3. Now look what happens. I have a period of pi. I've got to go all the way down and then back up here. I have to be back up here by pi. So halfway in between, I got to be down here. And half of those halfways, I got to cross my x-axis. Those are my key points. I'm not going to make a t-chart and graph this forever. I mean, I could do that, but those are my key points. So it's going to bottom out here. It's going to peak up here, and I'm going to have, for this problem, those as x-intercepts. And this continues, but I'm going to stop after this part here. Well, maybe I'll put one over here. Down here and here. So this is going to be kind of a stretched out, skinnier looking graph. And this is going to continue. This is going to come down and then back up and down and try to be as neat as you can and back up. Oops, that's not so neat. Try to be as neat as you can, and then I messed up. There we go. That's why you always graph in pencil so you don't mess up. And then have to redo the whole thing. You can just erase. And there's the graph for problem number 9. So I used to teach with these kinds of graphs, first graph the parent, then graph the vertical stretch, then graph the horizontal stretch, one right after another, so that you could kind of do it in stages. But I think with only a vertical and a horizontal shift, excuse me, I just said shift, stretch or compression, vertical stretch, horizontal stretch, you can do this in one graph if you're careful. But it starts out by knowing this information and using this information to come up with a halfway decent graph. Now, the only way you're going to get good at this is by trying them out. So you need to try these problems and not just look at the answer guide to help you out, because you're never going to be able to know enough information, to reproduce that information on a test or a quiz. So you need to practice this stuff. And of course, if you have questions, I can help you with it.